So Design That Matters started in newborn health about 6 years ago, 7 years ago. We started looking at infant phototherapy, a treatment for a condition called jaundice, which actually affects 2/3 of newborns. And what we found is that although the device exists to treat jaundice, it is not a good match for a hospital, say in rural Vietnam or Cambodia or Laos or in Africa. So the question was, could we take this device that exists and adapt it to this other setting? Devices that exist are intended for US, Europe, Japanese, Korean hospitals. So really good hospitals that have well-trained staff, lots of equipment, and money to pay for maintenance and spare parts. In countries with less resources, there are fewer staff who don't have as much training, and they have no money for spare parts. So how do we adapt that device to this new context?
So what is the most difficult thing when you do this work?
So one of the most difficult things about this job is understanding the difference between what people say and what people do. So if we go to a hospital and we ask a doctor, do you have any trouble using this device? Oh no, no trouble, it's perfect. And then we observe what they do, and maybe they never use it, or they're using it incorrectly. What we found, and this is universal, is that everybody's a genius. We have to learn how to ask questions. So for example, if we ask a nurse, do you have trouble using this device? The nurse will say, no, it's easy. I'm smart. Okay. Do you think she would have trouble using this device? Oh yeah, it's really complicated. It'll never work. So we have to learn. I think that that's been one of the more challenging things, because so often we're giving presents at a holiday to your children, and you can give them the gift that you want to give them, maybe a book about math, or you could give them the gift that they want to receive, a video game, a toy, a bicycle. And so similarly, when we're working in design, we can give somebody a product that we think they need, or we can try to figure out the product that they want. And there's often a big gap. WHO, the World Health Organization, estimates, so first of all, most medical equipment in low resource countries is donated, either by the government or an overseas donor or an aid agency. So most of the equipment is donated. The WHO, the World Health Organization, estimates that only 20% or 30% of that equipment is ever turned on once. It's a terrible, terrible waste. So it's like giving your daughter a math book and thinking that she's going to learn math, but if she never opens it, it was a waste of time. So we need to understand what the real obstacles are to using a piece of medical equipment, what makes it intimidating or what makes it confusing, and then design for that. That's our job.
So for you, what's the design?
So all of Design That Matters products, you could say like poetry, they rhyme. They're not all the same, but there's something that they all have in common, which is that we try to find an existing medical device and make it hard to use wrong. Think about like a laser printer. When they first came out, or a photocopy machine. When photocopy machines first came out, if you got a paper jam, you had to call somebody to come and fix the photocopier because nobody knew how to fix them. Over time, they made the photocopier such that your average person can fix 90% of the problems. If you've ever opened up a printer or a photocopier and there's numbers and there's, it's pretty easy to figure out how to open it up and take things out. So that's designing around complexity. In a sense, that's what we're trying to do with medical equipment. One of the big challenges with newborn health is in a rural hospital, many rural hospitals don't treat babies at all. So if a baby is admitted to the hospital with jaundice or hypothermia or pneumonia, they will immediately refer that baby to a bigger hospital, maybe in the capital. Our argument is that if we make an easy-to-use medical device, if you have to wait until they go to the capital, the capital hospital, they get sicker, sicker, sicker. So by the time they get there, they're very, very sick. And many of these kids are dying. And so, again, part of our philosophy is how do we make it easy to treat basic conditions like jaundice, like hypothermia, in a rural hospital.
So how many medical devices your medical devices are using all over the world?
Sure. So Firefly, our newborn phototherapy device, is now in 24 countries, from Afghanistan to Zimbabwe, and we've now treated so the devices distributed by our partners, MTTS in Vietnam, have now treated over 100,000 newborns. And of those babies, about 10% of them, if they hadn't received treatment, would have experienced permanent disability or death. So 100,000 is fantastic, but we have a long way to go. Our goal is millions.
What about how many devices?
So I think that now we're hundreds of devices, more than 600. I'd have to check for sure. So our target over the next year is to distribute over 1,000.
Okay. Then how is the distribution system? So is it for retail base or just funded by some organization?
It's a great question. And actually distribution is one of the more complicated. One of the things that we've learned is that design is hard, right? Doing what we do, making great medical devices is challenging. Compared to distribution, it's in some ways the least hard part of the process. One of the biggest lessons for me personally in doing this kind of work is that the design is not enough. If we make something great, who cares? We'll put it in our little museum, people will come by and see it, we won't treat anybody. So really, partnerships are the most important part of the process. First of all, when we got into doing Firefly, I didn't know anything about newborn health. I didn't even have children when we started. So we needed experts to teach us what is jaundice, what is newborn health, what does effective treatment look like. So there's partnerships at the identifying the problem side. Second, when we designed the product, we're a very small office. 220 volunteers worked on the design of Firefly. So that's students and professional volunteers. So students working through university courses at MIT, for example, the Rhode Island School of Design, would develop prototypes. Professional volunteers would help us turn a prototype into a manufacturable product. All the while, we were working with a distribution partner. So we have two distribution partners. MTTS in Vietnam is a medical device manufacturer. They also distribute medical devices. So they have a suite of newborn health technologies. So they're, for us, the perfect partner. Because they can tell us when we're doing the design, concerns about cost, concerns about manufacturing processes. And they can own, basically when we hand them the design, they own it. Similarly, we've partnered with organizations like East Meets West, Thrive Networks, different distribution organizations, training people how to use them, and then having a long-term relationship to see that if there's an issue with the device, somebody's there to fix it or replace it. Buying Firefly units, so in Myanmar, there are now 200 Firefly units. We're treating something like 25% of all the jaundice newborns in Myanmar. Many of those units were actually bought by the government directly. So we see a mix. Some is philanthropy, some are private hospitals that are buying the equipment, and some are governments or large aid agencies who are buying the equipment.
Just compare with the normal the medical device, and then with yours, and then how much gap is how much different with the price
90%.
range?
So there exist overhead phototherapy devices that are over $10,000. Firefly is less than $2,000. So we've taken out 90% of the cost of a conventional phototherapy device.
Wow.
And it's more effective. Firefly has, and maybe later you can get footage to show that it's from above and below. So Firefly is actually treating babies in roughly a third less time than a conventional device. So it's cheaper and it's better.